When we're creating the compound, remember again that we just need to remove anything that is literal, that is an actual reference to an actual in-scene object. And in that case, the emitter and wind objects meet those requirements. So I'm going to pull those out of the graph for now. They're actually going to be connected as the first two inputs for our compound, and as such are going to provide two inputs for me free of charge. So we always need to, well, we don't need to, but I'm going to insert an execute node so that I can interrupt the stream of all of these nodes executing into the ice tree, so that I can pass a single execute output into the ice tree, so for ease of connection later on. And then I'll grab all the rest of the nodes, including the comments, and make a compound out of them. Again, we'll just leave the compound in place, because if we ever need to explode the compound, it'll explode into its original location, and we won't have any overlap between our inputs. I'll edit the compound, and we'll call this the thick smoke. And I'll export that into the ice category. And then it's just a matter of exposing whatever values we need here. So likely things like the rate. Size isn't really going to need to be affected, because we're affecting that with another compound later on down the line. We're not going to really need to control shape. Perhaps initial speed would be useful on the emit from surface. And then as far as the age limit goes, we might need to be controlling the minimum age, the maximum age, and the scale of that effect. So we'll call this one min age, max age, and we'll call this turbulence scale on age. Maybe even control the animation speed, although that's probably a little bit too much for controlling the age limit. We'll do that to more the particle position. So when I get the particle position, the variance I want to control, so we'll call this variance on position. Turbulence scale for the position, and the speed. I'll also control the upwards force, variance, turbulence scale, and animation speed as well. So this would be the force, turbulence scale for the force, the wind force, and the animation speed for our force. Okay, and we could also control our directional vector. So this one represents our upwards force, but it could be used to move the particles left or right if we wanted to add a small value to the directional vector, or to oppose it for that matter. As far as dealing with the age percentage of the particles to control spin, and I should actually make a note here, I'll access the profile of the function curve. So this is the profile on spin at age percentage. And the multiply, we'll call this the spin factor. And that should be good there. And finally we'll expose the profile curve for the particle size and the multiplier. So profile, multiplier, so this is called the size profile. Size multiplier. And same thing for the color. We'll take in the gradient, and that should really be it. That's all we really need to control there. So we'll call this the color gradient. Alright, that takes into account all the values we need to expose for the smoke effect. So now all that's left to do is to just do a quick compound properties, right click on the compound and compound properties to just get the author, and compound to create a thick smoke effect. So example, smoking hulk of a building. It's at version 1.0. That should be good enough for now, and I'll export that. So I'll export it to the ice folder where it should show up. I'll clear off my filter menu, and if I look under Tool Ice, I should find my thick smoke effect. Okay, great. So if we have a look at our effect one last time, the next thing that's of course left to do is render the effect, but we'll be using the volumetric shaders to do that. We may have to come in and tune some of the parameters like size and color in the 3D viewports here or within ICE to work with the render tree, but that's okay. Okay, so we'll move on to the rendering now, or to the shader setup and then the rendering.